Sometime around the turn of the 16th century BC, the eastern Mediterranean was hit by one of the most devastating volcanic eruptions in human history. It happened towards the late Bronze Age, on the Greek island of Santorini, also known natively as Thera. This eruption probably counts as the second largest eruption during all of recorded human history. Its effects on Bronze Age civilization were far-reaching. Even today, some 36 centuries after it happened, the evidence of its ashfall, earthquakes and total tsunamis is still clearly visible in archaeological sites across the region. The devastation caused by this eruption almost single-handedly brought down the Minoan civilization on Crete and permanently altered the course of Greek history at a time it was still nascent. It can be argued that in the 3600 years since, no other eruption has had a greater impact on the course of human civilization than this one. The Santorini volcano is located on the like-named island of Santorini, located some 120 kilometers north of Heraklion and some 230 kilometers southeast of Athens. In ancient times, the island was also known by its native name Thera, but for this video I will be sticking to its modern, originally Venetian name, Santorini. Santorini is a part of the Hellenic volcanic arc that stretches on for some 500 kilometers across Greece and the southern Aegean Sea in the eastern Mediterranean. Comparatively, this is one of the world's smaller volcanic arcs that consists of just some 10 principal volcanoes. The Santorini volcano itself sits on the Eurasian plate, the largest continental plate in the world. Here, in the eastern Mediterranean, the African plate subducts underneath it at approximately 2 to 2.5 centimeters per year. This process is slowly raising the crust in the region, and over the next 50 million years or so, the basin is expected to transform into a vast mountain range larger than the Himalayas are today. Today though, that process is only in an early stage, with the Atlas, Pyrenees, Alps, Alanidas and Taurus mountain ranges the first signs of what is forming here. This mountain building process called orogeny creates plenty of volcanic activity across the Mediterranean. While it is true that volcanism here is on average not as frequent as in other volcanic regions, the Mediterranean basin is no stranger to violent eruptions, of which the 1600 BC Santorini eruption easily stands out as the largest in the region across the entire span of recorded human history. Santorini is a volcanic caldera that is only the latest iteration of a much older volcanic system that formed the island of Santorini around 650,000 years ago. Recent sampling of the surrounding seabed reveals that during the Pleistocene, Santorini was the site of earlier, violent eruptions around 520,000 and 180,000 years ago, both of which might have exceeded the Minoan eruption in scale. From that same sampling, it is revealed that the Santorini volcano, prior to its 1600 BC eruption, had been through a period of relative quiescence lasting at least 900 years. Santorini possesses what is called a transcrustal magmatic system, consisting of a deep basaltic reservoir located some 12 kilometers down, which fuels into a shallower silicic reservoir located some 4 to 8 kilometers below the caldera. These two chambers are connected by a network of dikes and sills, allowing magma to gradually rise upward through buoyancy. Unlike with stratovolcanoes, where the buoyancy pressure alone is enough to eventually overcome the rock's integrity above and trigger an eruption, caldera systems like Santorini are able to divide the pressure across their system, allowing them to operate stably at high pressure levels for centuries or even millennia. What eventually causes the eruption is a runaway spike in pressure when the magma starts to crystallize, squeezing out water that instantly turns into gas, raising the pressure catastrophically until the roof of the shallow chamber is breached. Greece at the turn of the 16th century BC was not in any way recognizable as the Greece we know today. 3,600 years is an incredibly long stretch of time that takes us all the way back to a period well before the classical Greek cities of Athens, Sparta, Corinth and Thebes, to before the Homeric period, well before even the Greek Dark Ages, and all the way back into the late Bronze Age. Greece at this time was dominated by the likely pre-Indo-European Minoan civilization centered around Crete, while on the mainland the newer Proto-Greek Mycenaean civilization was on the rise. The Minoans were a powerful naval civilization, and Santorini existed well inside their sphere of influence. On the island itself, the settlement of Akrotiri existed, which might have possessed some regional variety of Minoan culture, but is nevertheless identifiably Minoan to archaeologists today. Located in a strategic position between the Minoans and Mycenaeans, Akrotiri likely served as a major Minoan trade hub between these two civilizations. The 16th century BC is so far back that writing was only just starting to develop in Greece. The Greek alphabet didn't exist yet, and at the time of the eruption, the region was using the Linear A script. Linear A remains undeciphered to this day, and consequently, native records of the eruption, if they do exist, are unreadable to us. And instead, most of what we do know about this eruption is deduced from the archaeological record. From this archaeological record, we can estimate that at the time of the eruption, the population of mainland Greece was probably no greater than just 300,000 individuals. While on prosperous Crete, one of the densest population centers in the region at the time, some 200,000 people might have lived. And on the island of Santorini, the settlement of Akrotiri probably hosted little more than 1,000 inhabitants. "3,600 years is a vast amount of time. So vast that naturally some debate has arisen around the precise dating of the eruption. For most of the 20th century, the eruption was believed to have occurred sometime around 1525 BC. This date was proposed by archaeologists attempting to synchronize Minoan artifacts with Egyptian ones, particularly those of the 18th dynasty at the start of the New Kingdom. This is supported by various clues, such as Minoan pumice found in the New Kingdom layer, New Kingdom pottery found in Akrotiri, and even an inscription in the tomb of Ahmose I recording a disaster seemingly similar to the eruption. The argument thus goes that since we know the 18th dynasty is dated to roughly the later half of the 16th century BC, that is when the eruption must have occurred. However, this date does not match with more recent scientific findings. Radioactive carbon dating of the soil around Santorini points to the eruption occurring much earlier, around the end of the 17th century BC. By analyzing tree rings, we can get even more precise, because they can pinpoint us towards an exact year instead of a range. One olive branch found in Akrotiri specifically points towards 1614 BC. Furthermore, at the time it was buried, it had leaves growing, which might further indicate the eruption happened around late spring or summertime. Most of the eruption's ashfall was also blown southeastward. That could be a total coincidence, of course, or it could be the result of the Atassian winds dominant in Greece during summertime. Today, the community largely favors the earlier eruption date around 1614 BC, but the discrepancy with the Egyptian chronology is puzzling. Could it be that our understanding of the timeline of ancient Egyptian history is off by almost a century? To be honest, we don't know, but in my opinion, the most educated date for the eruption is during the summer of 1614 BC. Prior to the eruption, the geography of Santorini was very different than how we know it today. Nowadays, Santorini consists of 3 outer islands, forming the rim of the caldera. These are Santorini, Therasia, and Aspronisi, with the caldera connected to the Aegean Sea at 3 access points. Inside the flooded caldera, there are 2 more islands, Nea Kameni and Palea Kameni, which are located directly on top of the volcano. But back in Minoan times, Santorini had a very different geographical layout. Ancient Thera was a single 30-kilometer long crescent-shaped island forming a nearly continuous rim around the flooded caldera, which back then only had a singular access point to the Aegean Sea in the southwest. And instead of 2 central islands, ancient Thera likely only had just one, which may or may not have been connected to the ring by land. Some debate about the exact details of this layout persist, but generally this represents the most realistic layout of Minoan Thera at the time of the eruption. The Akrotiri settlement sat on the far south side of Thera, on the coast, not far from where the modern village of Akrotiri is located. Deep below the caldera, the shallow magma chamber was now approaching critical condition. Having had its last meaningful release almost 1,000 years earlier, pressures were now exceeding those found at the bottom of the Marianas Trench, and temperatures might have went up to 1200 degrees Celsius. Under such conditions, the magma had begun its crystallization process, spiking the pressure up rapidly as steam began to accumulate in the chamber. With the shallow chamber now less stable, the surface would have almost certainly received advanced warning signs of the pending eruption, in the form of frequent earthquakes and perhaps even some minor steam eruptions, as the magma would have met resistance from seawater sipping into the vents. Evidence of increased activity during the lead-up phase is backed up by excavations at the Akrotiri settlement, which show repairs on damaged buildings before they were buried in ash. In fact, the main ash layer of the eruption in Akrotiri contains no human bodies at all, which seems to suggest the inhabitants abandoned the settlement before the main eruption started, likely as a consequence of the intensifying volcanic activity. Whether or not they consciously knew what was coming, or life had simply become too big of an inconvenience on Santorini at that point remains anyone's guess, but evacuating the settlement was definitely the right move. So by the time we get to the main eruption, it is unlikely anyone was actually still on the island, with the inhabitants most likely sailing for Minoan Crete sometime before the eruption. Which was good for them, because what happened next was an eruption not topped in scale for another 32 centuries. Based on deposits found in Akrotiri, archaeologists today subdivide the eruption into 4 phases. The first of which began when, after months of tremors, the runaway pressure spike inside the shallow magma chamber finally reached its breaking point. The chamber's integrity could no longer contain the immense pressure of the magma and breached catastrophically. Excavations suggest that this initial eruption originated from a main central vent and did not involve any of the many smaller vents around the volcano at this point. It was thus most likely centered on the original central island. Ice cores recovered from Greenland show massive sulfate and nitrate spikes around this time period, which allow us to approximate the scale of this initial eruption. In order to produce those results, the yield of the initial eruption would have had to measure at least 100 to 500 megatons of TNT. That is an insane yield, easily putting the Santorini eruption ahead of even the most powerful nuclear weapons ever detonated by a factor of 10. Such a powerful rupture would have effectively blown up the entire central island and launched ejecta up into the atmosphere at speeds of over 600 meters per second. Such a violent explosion would have generated an immense audible shockwave similar to those released by the eruptions of other volcanoes such as Krakatoa and Tambora. At a scale of hundreds of megatons, such a blast would have been powerful enough to have been heard from thousands of kilometers away. Even if we assume the lower end of that yield spectrum, the blast wave would have easily traveled all across the eastern Mediterranean to be heard across Greece, Anatolia, ancient Egypt, and possibly even the Levant. It is thus likely that all ancient civilizations in the region at the time would have been able to hear the eruption. Analysis of the seabed surrounding Santorini, as well as the depth and compositions of ash layers in archaeological sites across the region, allow us to deduce that this initial Planaean stage of the eruption probably released at least some 20 cubic kilometers of ejecta into the atmosphere, forming a towering ash column that could have extended at least 36 kilometers high, well into the Earth's stratosphere. In Akrotiri, which was only some 3 kilometers away from the center of the eruption, the destruction was total. Within just a few minutes after the blast, pumice rocks would have begun to rain down on the settlement, not stopping for days until the settlement was completely buried. The weight of the pumice blanket would have been enough to collapse buildings, with the archaeological ash layer on top of the settlement some 4 to 6 meters deep. On nearby Crete, some 110 kilometers away from the eruption site, the debris was finer and would have continued falling for days, while inland areas may not have seen much more than 5 centimeters of ashfall. At the northern shore, closer to Santorini, the layer of ash was as deep as 20 centimeters. While not enough to destroy towns or collapse buildings, this would have buried farm fields, destroyed harvests, and ruined water sources. Buildings at the Minoan cities of Knossos and Malia also show earthquake damage from this period, indicating that Santorini definitely had some reach. Further away, across the Aegean Sea in Anatolia, some 400 kilometers away from the eruption, the ash layers found are just 1.5 centimeters deep. Due to the increasing distance, the particles managing to stay airborne till here are of an increasingly finer nature. And by the time we get to Egypt, some 900 kilometers away from Santorini, there isn't much left except the finest of particles. The ash layer found here is only about half a centimeter deep, suggesting the effects of the eruption in Egypt could have been no more than an inconvenience, with hazy yellow skies that could have been easily misinterpreted by the contemporary population as just a strange sandstorm. Nothing worse. From just the stratigraphic record, it is difficult to say precisely how long the initial Planaean eruption would have continued. But, based on the volume of the shallow chamber, most of the steam could have been exhausted in the first 48 hours of the eruption, after which it would have transitioned into a more effusive, magmatic eruption. At this point, the top of the eruption column would have been spread out like an umbrella into the stratosphere. Instead of drifting away in the wind, the majority of the column had stayed airborne above Santorini up to that point. But now that the ejecta had reached such great altitudes, it cooled and lost its atmospheric buoyancy, causing gravity to take hold on the column. The following collapse of the column was truly cataclysmic. As the still hundreds of degrees hot ejecta plunged into a 36 kilometer fall back towards the surface, it accelerated to truly immense speeds, enough to rain down an incinerating bombardment of hellfire on the island. As the ejecta impacted the ground, it superheated the air, causing it to rapidly expand outwards, sending violent pyroclastic flows in all directions. The buildings at Akrotiri only managed to survive this because by that point they were already buried in ash and pumice, which meant the pyroclastic flows simply went over top of them now. In the long term, this meant the burial actually helped preserve the buildings and frescoes for later archaeologists. At 36 kilometers tall, the collapse of the column would have been visible from an incredible distance, even hundreds of kilometers away. At that height, it would not disappear behind the horizon for at least 700 kilometers given clear weather conditions. Imagine for a second the evacuated Akrotirians watching the destruction of their island all the way from Crete. It paints a truly desperate picture. The bombardment would not have lasted for very long, as the eruption column quickly depleted itself in a matter of just a few hours. But now, a rain of ejecta from the collapsed column had fallen back upon the central vent and blocked it. This might have resulted in a brief moment of eerie peace and quiet on the island. Deceptive though, as now instead the eruption shifted towards the multitude of smaller fissures, mainly running along the northern side of the volcano, signaling the start of phase 3 of the eruption. Along the northern rim of the volcano, evidence of at least 3 vents has been found. But it is entirely possible that there could have been even more active at the time. With the main vent now effectively sealed, the eruption shifted towards these vents, proceeding into a more effusive stage as the contents of the shallow magma chamber now gradually bellowed out through them. From this process, fresh new pyroclastic flows occurred, but unlike those before, these were denser, more liquid, proper lava flows moving at fast speeds between 50 to 100 km per hour. As these cooled, they formed dense layers of ignimbrite rock that expanded the island northwards into the sea. Miraculously, Akrotiri managed to endure this too, because once again, it had already been buried during the initial eruption, causing the heavy lava flows to simply go underneath it, just like before, sparing the buildings and Odd from further destruction. The main eruption phase would go on to be the longest of them all, and for the next week or two, the shallow magma chamber would have gradually emptied itself of its contents. As this was happening, its internal pressure gradually subsided, and the chamber began to deflate like an exhausted balloon, causing the island above to begin sinking. Gradually at first, but as the eruption continued for weeks, the entire caldera started to become unstable. This sinking would eventually culminate into the total collapse of the Santorini caldera. The shallow magma chamber, which had previously held some 30 to 60 cubic kilometers of pressurized magma, was almost completely drained of its contents by the eruption. And now that the eruption had exhausted itself, this empty chamber had effectively turned into a giant sinkhole, causing the chamber's roof to cave catastrophically. First, a singular rupture alongside the chamber's perimeter formed, and the roof dropped suddenly by tens of meters, swallowing the ground above with it. The shock from the suddenly displaced mass generated an immense earthquake in the flooded caldera above. Within minutes, a second collapse followed, and over the next few hours, the caldera sank in stages by as much as 400 meters into the magma chamber below. Each new collapse displacing several metric tons of material and generating powerful earthquakes, which slushed the water around the caldera with enough force to stir up tsunamis rushing out into the Mediterranean up to 40 meters high. Today, it is estimated that the total volume of material displaced by the collapse was up to some 40 cubic kilometers. Because the collapse happened in stages across several hours, that also means there would have been a sequence of tsunamis. At a distance of just 110 kilometers, Crete would have been the primary victim of these, and models suggest that Crete could have experienced tsunamis up to 30 meters tall, which definitely would have caused widespread devastation even well inland on the island, with Minoan coastal settlements such as Malia, Zakros and Gornia all showing major tsunami damage from around this time. This would have devastated coastal harbors and explains why Minoan naval power never really recovered after the eruption. In Anatolia, sand deposits at sites such as Kavos indicate that they too were subjected to the tsunamis, though not as tall as they had been in Crete. Even in Egypt, some 900 kilometers away, there's evidence of 1 to 3 meter tall tsunamis hitting the Nile Delta. While the damage at that range was not as extensive, it still shows how grand the Caldera collapse was. When the eruption ended, the destruction on Santorini was total. Akrotiri had been completely buried by ash and pumice. Thick, hardened ignimbrite covered vast swaths of land, and the Caldera collapse had forever altered the entire island's geography. Nevertheless, Akrotiri shows signs of digging not long after the eruption, showing that people did eventually return, possibly to search for belongings left behind in a rush. However, the archaeological record does not support them staying to rebuild though. Instead, only a few decades later, Mycenaean pottery shows up on the island, indicating a new population of settlers had made their way to Santorini in the wake of the eruption. On neighboring Crete, the Minoan civilization had been nearly brought to collapse. In only a month's time, a once thriving maritime empire was transformed into a society struggling for survival. Its mighty harbors lay in ruins from tsunamis. Farms were buried in ash, which had ruined harvests and caused widespread famine. and many homes had been so damaged by earthquakes that the island was probably dealing with a refugee crisis. Minoan civilization did eventually recover somewhat, but it was only a shadow of what it had once been. Their power now greatly reduced, resulting in them gradually losing their cultural and political dominance to the rising Mycenaeans on the mainland. And in the following centuries, the Minoan civilization gradually gave way to the early Greeks. For obvious reasons, it's difficult to assign an exact death toll to the Minoan eruption. But it is not unimaginable that in the short term, some 50,000 could have been killed directly by the eruption, primarily on Crete. After that, indirect effects of the eruption such as famine and disease could have later raised this number to over 150,000. These are only estimates of course, but it shows just how utterly devastating large eruptions such as the Santorini can be near population centers. A way to measure the size of eruptions by ejecta volume is the Volcanic Explosivity Index. It runs logarithmically from 0 to 8, with high-end eruptions being the most rare and violent events. On this scale, the Santorini 1614 BC eruption ranks comfortably as a Phase 7 eruption, and as such has few equals in scale throughout human history, with only the 1815 eruption of Mount Tambora definitively confirmed as having ejected more material than this one. It is estimated that a total of at least 40 cubic kilometers of ejecta was pumped into the atmosphere. Much of that would have stayed airborne in the form of sulfate aerosols for months after the eruption, creating a haze effect in the atmosphere that blocked sunlight. In the areas immediately proximate to the eruption, the sun would have struggled to penetrate for days. But as natural weather patterns began to distribute the aerosols globally, a pale yellow haze enveloped the ancient world in a volcanic winter. The most famous example of such a winter is the year without a summer in 1816, triggered by the eruption of Mount Tambora. But there is good evidence that Santorini managed to accomplish the same effect some 34 centuries earlier. Ancient Egypt records unusual storms and darkness striking Waset during the rule of Ahmose I. Some have interpreted this as a tentative account of the eruption and its volcanic winter. However, like I mentioned, there exists a sizable date discrepancy of almost a century between the rule of Ahmose and when we believe the eruption actually happened. Further away in ancient China, the bamboo annals speak of yellow fog, a dim sun, frost in July, and famine at the end of the semi-mythical Shaya dynasty, which chronology aligns more closely to 1618 BC. These events would culminate into the fall of the Shaya dynasty and its replacement with the Shang dynasty, which established the infamous Mandate of Heaven. Another interesting fact is that the time of the eruption seems to roughly coincide with the extinction of the last mammoths on Wrangel Island. As far as I can tell, a connection hasn't been scientifically investigated, but it's interesting to note those events seem roughly contemporary. Less scientifically, some have even tried to connect the Santorini eruption to the biblical Exodus and Moses, with the volcano and its volcanic winter supposedly responsible for the 10 plagues of Egypt. The Santorini would go on to erupt several more times in the following centuries, with its most recent eruption in 1950, but none of those later eruptions would even approach the scale of the Minoan eruption again. Ever since I'd finished my video on the Tambora, I'd wanted to do one about the Santorini, because while it's true there have been other Phase 7 eruptions throughout recorded history, I think these two have easily been the most impactful on humanity. So I'm hoping you found this video informative. Due to the sheer amount of time elapsed since it happened, there was a lot of uncertainty to dig through about the specifics of this eruption. If you are into volcanology, I got another video covering the 1815 eruption of Mount Tambora for you to check out. It might be a while, but if this video does well, I might cover another eruption. So let me know in the comments what you'd like to see next. And while you're there, give this video a like and subscribe if you want to see more. It really helps me out massively as a small channel, so thank you very much if you do. So as always, thank you so much for watching. This has been YiGi Online, and I'll see you in the next video.